Audio Jungle. Audio Jungle.
Right. So the problem is that draw BMD, draw BMD bending moment diagram for simply supported. Draw BMD for simply supported beam subjected to 3-point loads, and the beam is just like this. And if you see here, this is the beam, and this will be the reaction force. Basically, just say this end is what A and this end is what B. So obviously, we'll have a reaction force which is RA, and this is nothing but RB. Okay, and the 3 points loads are 5 newton, 10 newton, and 8 newton, and dimension it is given from end A. This is what 2 meter, and say this point is C, this point is what D, and this point is what E. So all the dimension they have given. So first step, as I have mentioned already, first step is to calculate reaction forces. That is RA we have to calculate, and we have to calculate RB. This is the first step we have to perform, okay, in the problem. Now, so we have a equilibrium equation. What is the equilibrium equation? You have to take moment for calculating of RA and RB. You have to write moment equations. You have to write taking moment about point A, MA, and this is the equilibrium equation, means summation of the moment or moment equivalence, or you can say moment about point A equal to 0. So because of all the forces, you have to write moment at point A and make it equal to 0. So it is called moment equivalence. Okay, now if you take moment about A, so this 5 newton, this 5 newton will give the clockwise moment about A. So 5 newton into this 2 meter. So because 5 newton meter will 5 newton force will give the clockwise moment, so it is plus pi into the distance is nothing but from point A, the distance is 2 meter. Distance is 2 meter. Similarly, check next force, it is 10 newton. This is also clockwise moment. 10 into from point A, what is the distance? 2 plus 2, it's 4. It's 4. Then again, next force is nothing but 8 newton. This is also clockwise about A. So 8 newton is also clockwise about A, and the distance is 2 plus 2, 4 plus 3, 7. Now see, next force is nothing but reaction force RB, which is in upward direction. So this upward direction reaction force about A will give the anti-clockwise moment. You just check the sense. How you will check the sense? You talk first like this force, 5 newton. So about which point you are taking moment? So it is point A. So just fix this point A now, and you just check the sense of the force, and you just make a circle, and inside the circle the center should be there. Center means about what point you are taking moment. You are taking moment about point A. So this point A should be enclosed by this circle, and see the circle uh, intention is what clockwise, because this 5 newton is what going down, so it will go in this way, and it will be the clockwise moment. So see, this is the clockwise moment. At the same time, in this way you can understand, this is the simple logic. Okay, this is the simple logic. So similarly, this 10 newton will also give the clockwise moment about point A, and 8 newton will also give the clockwise moment about A. But if you talk about the RB, so RB will be going in upward directions. If you want to take moment about point A, so you have to make one circle, and inside the circle point A should come. So if you see the A is, because RB you are talking, so now this is the, you can say this is the point. Now it is enclosed by the point A is what enclosed inside this circular whatever you have drawn. So now this RB, if you see this intention of this RB will be the anti-clockwise moment, right? about point A. Hope you understood about this clockwise and anti-clockwise, how to take this, right? So now RB will give the anti-clockwise moment, and so obviously, so RB will be the anti-clockwise moment, and rest other forces will have a clockwise moment about point A. So this is now RA. So 8 into 7, now RB will be anti-clockwise moment. So RB into from point A, what is the distance? 2 plus 2, 4 plus 3, 7 plus 1, that is 8. So it's nothing but equal to 0. Now if you say RB, right? So your RB is nothing but 100 by 8, 50 by 4. It's a 12.5 Newton. This is the RB now. What is the another equilibrium equation? Summation of all the forces in vertical direction, in y direction it must be 0. So what is the summation of all forces? All upward forces will be plus, and all downward forces will be negative. You can take all upward forces. What are the upward forces? Ra and Rb you are considering upward. So Ra plus Rb, these are upward, so this is plus. And all downward forces like 5, 10 and 8, all downward forces will be considered negative, so unequal to 0. So you have Ra, RB just now you got 12.5 minus 5 minus 10 minus 8. If you calculate RA, it's nothing but, if you check how much you will have, 23 minus 12.5. So it's nearby, how much you will get? It's 12.25, right? Sorry, it's corrected. This value is 12.25, na 25 by, so 25 by 2, right? So we have to correct this. This is the
It is 13.25.
56, 106. So how much it's coming?
13.25.
13.2. So this value is nothing but 13.25. You keep the value of RB 13.25. So it's nothing but 13.25. If you minus it, then approximate, you will get 9.75. So you got RA and RB. So basically RB is nothing but 13.25. It's a 13.25 Newton, and this RA you got just now, you have calculated, it's a 9.75. It's a 9.75 Newton, right? Correct. Now once you got the all forces for this beam, now you will go for the calculation of moment, right? You will go for the calculation of moment. So now we have to write bending moment calculation, because if you want to draw the bending moment diagram, so first you have to go for the calculation. So now we have bending moment calculation here. Bending moment calculation here. So we can give the naming, like we have, it is already named A, C, D, E and B. Okay. Now, so once you go for the calculation of the moment at each and individual point, so how you will calculate? See, now if you are, again I will draw, better I will draw the beam here. So the beam will be something like this. See, nothing but RA, which is nothing but 9.75. This is nothing but RB, which is nothing but 13.25. Newton, right? Newton. And here we have load. This load is nothing but 510 8. 1 meter, 3 meter, it's a 2 meter, and this is what, right? Okay. Now, so each and every points like A, B, C, D, and E, we have to calculate moment at each and every points, right? So if you go for the calculation of moment at point A, so for this you can write MA. If you write moment at point A, then you can write MA. Always remember, if it is just simple idea you have to get, if it is not if it is not a, uh overhanging beam, okay, if it is not a overhanging beam, if it is simply supported beam, so at the end points, it may be in A or it may be in B, that moment will be zero. Okay, that also we can prove. So end point will moment will be zero, like here at point A, that moment will be zero. But if you talk about moment, similarly, like here you have written moment at point A, it is nothing but MA. Similarly, you can write for moment at point B, it is MB. Okay. Sorry, next point is C. So you have to write next point, which is nothing but C. After A, it is nothing but C. B is here. Okay, this is the B and this is the A. So after A, we have C. So moment at point C. What is the moment at point C? Simple. If you see the moment point C, so that time you just cut this beam. I mean, separate diagram I will draw. Like if you are talking about point C, so only till point C you will have a beam. The right side portion you don't consider any force what it is available on right side. So if I say C, now this is the point C. So at point C, what is the load? It is 5 Newton, and this is nothing but 2 meter, and this load is nothing but RA, which is nothing but 9.7 Newton. If I'm calculating at C, so this right side we do not have any other part now, because we are talking point C. So till point C, what is the beam and what are the forces? For that we have to calculate moment. Like now for point C, so at point C, exactly at point C, 5 Newton load is there. So because of this 5 Newton, moment will not get at point C, because we do not have any perpendicular distance for 5 Newton, because it is exactly at point C and we are taking moment at C. So perpendicular distance will be 0. So we will not get any moment because of 5 Newton. But what about this RA? That is the 9.75. This 9.75 and the perpendicular distance is 2 meter, because we are calculating moment at C. So what will be the moment? 9.75, that is 9.75 force. And this will be clockwise. See the sense of this RA. This RA will give the clockwise moment like this. One circle will be formed and that will be clockwise. Okay, you can see in this way. I always uh, tell student, just whenever you will have a doubt, it is clockwise or anti-clockwise. So about which point you are taking moment, now you are writing moment about C. So this C will be your center, and for this particular force you just draw the circle. Now you have drawn, because this RA is what in upward direction, so this circle direction will be upward, means it is clockwise, right? So this will be the plus 9.7. What is the perpendicular distance? It is 2. So 9.75 is equal to 9.75 into 2. It's nothing but its value will be 19.5. 19.5. Now this is the moment, so Newton into meter. Okay. Similarly, you can calculate moment at point D. Okay. So if you write moment at point D. So again, because this is the first problem, so I'm just drawing this beam section, otherwise not required. So this beam now Up to what point you have to take? Up to point D you have to take. So at D, this is the D now. This is the point D. At D, 10 Newton load is what acting. This side beam, right side is nothing. And here one force we have. What is that? It's a C point, and which is nothing but 5 Newton. And this is nothing but RA, which is 9.75 Newton. This is 2 meter. This is 2 meter, right? Now you are calculating moment at point D. So now you just focus on the calculation part. So moment at point D is nothing but, first you will get moment because of this RA load, and RA is nothing but reaction, which is 9.75 into what is the, and this will give the clockwise moment at point D. So this is plus 9.75. What is the perpendicular distance? It is 2 meter plus 2 meter. It's a 4. And this 5 Newton, which is going downside, which will give the negative moment, that is anti-clockwise moment. Hence this is minus 5 into what is the perpendicular distance from point D, it is 2. And this will be the MD value. What is this? It is nothing but MD. You can write here or here, anywhere. So this is the moment at point D, means 9.75 into 4 plus minus 5 into. So if you calculate this value, so you will get 29 Newton meter. Then similarly, you can write moment. You can write moment What is the next point? It's a point A. Moment at point. So again, if you are writing moment at point E, so you have to write ME is equal to. Now till what distance you have to draw the beam? Now this will be till point E. So this is point E now. At point E, you have to check what is the load. It's nothing but
Sir, can't we take from
now if you are going to calculate moment at point E, so from A to E, what are the forces you have to take? Like at point A, we have 9.75, that is reaction force. Then obviously point C will be there, and that point C we have a 5 Newton. Then again point D will also come, so which is nothing but 10 Newton, and then we reach to point E. So because we are talking about point E, so we are moving from here to here, and we have to reach at point E. And after E, what are the forces? We don't know. So point is from where you have started at E, at A you have started, and where you are going to calculate moment, you are going to calculate moment at E. So from A to E, what are the forces? That forces you have to take for the moment calculation. After E, what are the forces? We don't care, because we till now we have reached at point E only. That's the reason we are writing moment at point E. So if you write moment at point E, so how many forces? 9.75. See, this 9.75 will give the clockwise moment about E. What is the distance? This distance is 2 meter. This distance is 2 meter. This distance is 3 meter. Okay. Now see 9.75 into the whole distance. How much? 2 plus 2, 4, and 3. This is 7 meter. See 5 Newton. This 5 Newton will give anti-clockwise moment about point E. Hence 5 into what is the distance? 2 plus 3, that is 5. Check 10 Newton will also give anti-clockwise moment about point E. So minus 10 into what is the distance? It is 3 meter from E. And this will be the whole.
this will come 13.25?
It's a 13.25, right? 13.25 Newton meter. Now simple, you have to write moment at point. Last point is nothing but B. See, after E we have a B. So it's B now. So now you have to, from where you are starting at point A, and you are reaching to point B. So complete beam you have to draw, and all the forces. So here force is 9.7 meter. Here we have a 5 Newton. Here we have a, I think, 8 Newton, right? 10 Newton. This is the 10 Newton. Then we have 8 Newton. Okay. So it's a 2 meter, 2 meter, and this is 1. All right. Now if you calculate moment at point B, so you can write MB, and till B, and after B what we have, we don't care. Actually this in B is the end point, but I'm saying this is the techniques you have to follow. Just like if you are calculating moment at this section, suppose this is A, this is B, this is C, D and E. If you are calculating moment, then till E only you have calculated all the forces. If you are calculating moment at point D, then till D you have to write all the forces. So same thing, if you are calculating moment at point B, then till B what are the forces you have to write. But actually this B is the end only, so we can write moment now. This 9.75 will give the clockwise moment about B. So this distance for 9.75, the perpendicular distance will be 2 plus 2 4 plus 3 7 plus 1, that is 8. And this 5 Newton will give anti-clockwise. Perpendicular distance will be 2 plus 3 5 plus 1 6. 10 Newton will give anti-clockwise moment, 3 plus 1 4. 8 Newton also give anti-clockwise moment, 8 into perpendicular distance 1. If you calculate this value, so what value you will have now? This is nothing but how much? This value will be 0, right? So always remember, so note, if this is the note,
Sir, it comes zero only, no?
0 you are getting,
Yeah.
right?
Yeah.
Yes. So you have to write the note, if beam is simply supported, if beam is simply supported, so at ends point moment will be 0. So now onward blindly you can write ends point moment will be 0. Here you have calculated, but now onward, if it is simply supported beam, so end points means A and B, directly you can write that moment will be 0. Okay, because you have proved here. So these two ends moment will have a 0. Now this is the node point, onward you can remember. Okay, done. So each and every points you have calculated moment, what you have taken, MA you have calculated 0, MB you have calculated 0, MC you have calculated 19.5 Newton meter, MD you have calculated, it's nothing but MD, it's 29 Newton meter, right? 29. ME you have calculated here, it's nothing but ME, it's a 13.25 Newton, 13.25 Newton meter. And obviously MB already you have written. So these are the moments, each and every points for the beam you have calculated. Now we are going for the bending moment diagram. Okay, now we can give the heading, we are now going to draw bending moment diagram, right, which is called BMD. Now you are going for the sketching, you have to draw. So once you are going to draw, it is SFD, shear force diagram or bending moment diagram, you have to take reference line. Okay, this is the now reference line. You can make it first beam here. So to draw the beam first, it will be easy for A, RA, RB. This is C point, D point, and this is E point. 3 points we have. Each points you have force. So at point C, what is the force? At point C, we have 5 Newton. At point D, we have 10 Newton. At point E, we have 8 Newton, right? At the same time, each and every points we have calculated moment also. So what is the moment at point A? It is 0. What is the moment at point B? It is 0. What is the moment at point C? It's nothing but 19.5, and it's a positive, hence it's a clockwise 19.5 Newton meter. If you check at point D, moment is 29 Newton meter, which is positive, so you take clockwise 29 Newton meter. And point E also positive, which is clockwise 13.25. Okay, so always remember, when you are going to draw bending moment diagram, so moment is your priority. If you are not writing the force like 5 Newton, 10 Newton, 8 Newton, also not useful, because already you have used and calculated moment with the help of these forces. So if you are talking about the moment diagram, then you have to concentrate on moment only. Like here I have shown you MA, MB, MC, MD, ME, all the moments I have shown you. So here if you see, all the moments are clockwise. Okay. So now this is the reference. This is called reference line. Above this we have a positive moment, which is clockwise. Below this we have a negative moment, which is anti-clockwise. So for time being, we do not have any anti-clockwise moment, only clockwise moment we are getting. So we'll start from all the sections. So you just stretch down these points, so it will be easy for you to show all the moments. Once you stretch down like this, and now you make the point A, B, sorry, A, and this is what C. This is C, D, E, and B. Now you have to check the magnitude of the moments, and based on this we should also aware about the table I had given. If between two, for the bending moment diagram, between 2 points, uh, between 2 points, if there is like points A and C, in between, if you are going to draw the moment, because this point A and C, in between this we have only point load. At A also we have point load, and at C also we have point load. We do not have any UDL or UVL. So for the point loads between A and C, if you draw the moment diagram, so it will be inclined. I have given one table. If you check, you will get. So at point A, what is the moment? It's a 0. So 0 will start from here. At point C, what is the moment? 19.5, which is clockwise. So means positive side you have to go. And what will be the curve? Curve will be inclined. I had given one table. If you open and check between the points load, moment diagram will be inclined only. So you got the inclined line like this. This is the value here. What is the value? It's 19.5. This value is nothing but 19.5 here only. Now again at point D, the load is again increased, moment is again increased. It becomes 29 Newton meter. Earlier it was 19.5. Now it becomes 29 Newton meter. Now this value is what? Now increased more. So this value will be increasing more. And again, this is between point loads. We do not have any UDL. We do not have any UVL. So this again point, these 2 points C and D will be meet by the inclined line only. So you can draw inclined line something like this. Okay. This is now this is C, D, E, B you have reflected here. So see, this is C dash. This is the D dash. Now come to point E. What is the moment at point E? 13.25, which is less than 29 Newton meter. But again, this E dash you can say somewhere here, because the magnitude is only 13.25, so it will be less only, because 29 reach here and 13.25 is less than 29, so it will come somewhere, it will come here. Now this D dash and E dash you have to meet by inclined line. Why inclined line? I told you, because it is only points load. D and it is in between only points loads we have. We do not have any UDL or U, right? So D E dash now you got. Now coming to this B, so check moment at point B, it is 0. So again this line you have to meet by this way, and which is nothing but obviously that slope will not be same here. You might, okay, maybe there will be confusion like this. The from this is the same line. No, it's not same line. Slope will be different here. So better I will show you nicely. Otherwise there will be confusion. So what my point is, this is like till this you got here. Right. This D dash you got 29 Newton meter, and at point E moment is 13.25. So I will mark here. This is now 13.25. This is the inclined line. And again, from here to, because now what is the moment here? 13.25 Newton. But at point B, what is the moment? It becomes 0. So you have to show the different slope. It will not be same line. Now this will be the another inclined line you have to meet from 13.25 to, now your moment becomes 0. So this will be called as a bending moment diagram, because all moments are clockwise. So you can say this is positive. If any moment is what anti-clockwise, so diagram will come downside also. But here it is only upward, and we are taking positive here. So you can uh, make it like this way. And in examination, most of time you have to show by the hash line, something like this. Whatever the PMD you got, you have to show by this hash line. Okay, if you are interested, you can show. Otherwise, not required also. So this is the basically bending moment diagram. This is the bending moment diagram for the particular beam. Then